Alright guys, so the last thing to talk about with trig really takes a lot of the elements we've already talked about and focuses in to one of the really important things that we need to know, especially if we're going into pre-calc next year, and really even if you're going into trig stats, because this is kind of like at its core what is super important about trig. So one of the things we talked about last week is sketching these angles. And so like if I'm sketching this angle here and I wanted to figure out what theta was, like the total length that this guy traveled, we talked about dropping that perpendicular to our x-axis, smushing theta up by the origin right there. Now truly if I wanted to find the full measure, this isn't really theta, this is what I'm going to call like theta. Because then I need to add on more because we want to know the full distance that we traveled. And down here they're telling me the point that I traveled to, so I went -1 this way, -1 that way, and so the easiest way to do this problem is to use tangent because I have opposite and adjacent. So tangent of kind of theta is equal to -1 over -1, which is just 1. And like if I want to know theta at this point, I kind of have to use the inverse function. And it would be really nice if I didn't have to use the inverse function, if I could just know what that is. So because I have to do tangent inverse on both sides to get theta alone, my thing is always I would love to not have to use a calculator. Now if you go and use your calculator, you'll get that theta is 45 degrees, but I did not use a calculator for that. Like I just knew that, and partially I knew that really quickly because if the two sides of a triangle are the same, then the two base angles are the same, so it would be 45. And then like if I want this full measure here, it's 45 more than 180 because I went 180 and then 45 more. So if I add 180 to that, we're at 225, which is one of those special angles that I talked about last time when we were converting ratio or radians to degrees and things like that. I had this whole fun circle for you, and really all those measures are super important because they all refer back to those special triangles, the 45-45 90s and the 30-60 90s. And so knowing those triangles quickly can be helpful for things like if I wanted to solve something like the sine of 30 equals x over 4, if I want to solve for 4 there. If I just know what the sine of 30 is, then I can figure this out really fast. Like the sine of 30, I know is half, and so then I can just solve for x, it's going to be 2. And like you can do that really quickly without a calculator. So that's kind of why we want to do this. And so what we're essentially going to create is a unit circle that incorporates our 30-60-90 triangle and our 45-45-90 triangle. So when I say a unit circle, I mean I'm going to take and on our xy coordinate grid, so here's x, here's y, we are going to draw a circle with a radius of length 1. So if I travel, I actually use black right here, if I travel out in this direction, this point right here, because I started at 0, 0 and ended here, is at 1, 0. If I go anywhere on the circle, so from the center out, let's say right there, I know that I've also traveled 1 in this diagonal direction. The real question though is like, what is that x coordinate right there? And let's say, for instance, we're going to start with this first one. Let's say that theta is 30 degrees. So we'll go with that first angle that we know, the smallest angle that we have, 30 degrees or pi over 6 radians. So if I know here that my radius is 1, the question is if I drop this down and I find that xy distance so I can fill in my xy coordinate point, the relationship that we have in a 30-60-90 triangle is that your hypotenuse is always double your shortest side. So across from my 30, I can take half, and so this distance that I traveled up is half. So my y value here is half. And then your longer leg across from the 60 is always root 3 times as much the smaller leg. So root 3 times half is root 3 over 2. So that's the x distance that I traveled. Okay. Now, I can take this point, and like there are a lot of different ways to think about this, but this is a really fun thing that I like. I can take this point and reflect it over, put it on the other side. And like this is the same triangle over here, it's just in a different quadrant now. So it's not 30 degrees, it's 30 above 180, so this is at like 150 degrees, or 5 pi over 6 radians, but it's the same point. It's still the root 3 over 2 comma 1 comma half, but now I'm in this quadrant, and in this quadrant x is negative, so negative root 3 over 2, and y is positive, so still half. And even better than that, I can take both these points and reflect them over your x-axis, so like this guy will pop down here and be like 30 below 180, so 210, or 7 pi over 6 if I'm in radians, but it's the same ordered pair, except now that I'm down in this quadrant, everything is negative, so negative root 3 over 2, comma half, and when I flip it over here, I can look at this point being reflected over, or this point, or whatever, but if I'm in this quadrant, x is positive, and y is negative. So, to talk about that for a second, why is that helpful? Well, that's helpful because if you remember last time, we talked about how sine of theta, when I'm drawing things on a coordinate grid, is always y over r. But in this case, r, my radius, is 1. So sine of theta is really just y. So this is sine of 30 degrees. And this is sine of 150 degrees. And this is sine of, so no matter where I go, if I'm 30 away from the x-axis, the sine of that will always be half, or negative half. Oh my word, I forgot the negative down here. Good thing I just looked at that again, because everything's negative. And if you remember, cosine of theta, when we were drawing on our coordinate grid, the little thing I did with you guys last time, or I'm sorry, 2 videos ago actually, cosine was always x over r, but my radius is 1, so really it's just x. So this is the cosine of theta, or cosine of 30 in this case. And like the super fun thing here, I'm just going to show you real quick, is if you go to your calculator and you type that in, like if I type in sine of 30, because that'll be easy to see that it's just half, so 30 sine is half. Now root 3 over 2 is harder to see because that's irrational, but if I take the square root of 3 and then divide that by 2, keep that little number in your brain, so the 0.866, blah blah blah, yuck. If I do 30 and then cosine of that, you get that exact same number. Now really quickly before we go on and create kind of the rest of it, tangent of theta in our coordinate grid, if you remember, was y over x, which that's really just slope here, and I have y and x, so I can divide those. So I can do, in this case here, get my red pen back, half divided by root 3 over 2, although we don't really divide fractions, we really multiply by their reciprocal, so this is going to be half times 2 over root 3, which the 2's will divide out, and you're going to end up with 1 over root 3 that you have to rationalize, which is going to be root 3 over 3. So then that's kind of your tangent value at this 30 degree point, no matter where I go, because whenever I divide, I'm always going to get the same thing. So this is root 3 over 3, root 3 over 3 for tangent, root 3 over 3 for tangent. The only thing I need to think about then is like if it's positive or negative. And so I can think about the quadrant that I'm in, and if tangent is positive or negative there, but I can also think about tangent as slope. I'm sorry, I'm talking really fast. This is so exciting. I freaking love this stuff. So tangent is really slope, because y over x is slope. This line has a positive slope, so it's positive. This line has a negative slope, so it's negative. Plus, I'm dividing the negative by a positive, so it'll be negative. This line has a positive slope, and a negative divided by a negative is positive, so it's positive. and then negative here because we had a negative slope. Okay, so that's kind of just 1/3 of the puzzle-ish. If we go to another spot on that circle, specifically here, when now theta is 45 degrees away, and that's important because it's a 45, 45, 90 triangle, I know that my radius is still 1. When I drop down that perpendicular, I could use, inverse functions to get this, but I can also use a 45, 45, 90 triangle relationship. And the relationship in a 45, 45, 90 triangle is that the legs are root 2 times as much, but I need to go backwards. So really, because I have the hypotenuse of 1, I need to divide that by root 2 to get back to the leg. So I have to rationalize by multiplying by root 2 over root 2, which is going to be root 2 over 2, which that's going to be how high and how far across you went, because the legs in a 45, 45 triangle are the same. So root 2 over 2 is the x and y value that you traveled, and that point can be flipped over here, and it's the same point except you're in this quadrant now, so x is negative, and you can flip it down here, and everything will be negative because you're in this quadrant, you're in the 3rd quadrant. And then you can flip that boy over here, and again, like, they're all 45, 45 reference angles, but they're not necessarily 45 degrees. Like in this quadrant, this is 45 away from 180, so that would be, oh my gosh, what, 135? Yeah. Or if I'm in this quadrant, I'm at 225 because I'm 45 away from 180 in the other direction. Or in this quadrant, it's 315 degrees. Or if we're in radians, any of the pi over 4 stuff. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Now, just like with the rest of them, cosine are my x values, sine are my y values. It's kind of nice because with 45, 45 is the same, but I do need to think about if I'm positive or negative. So I need to think maybe about what quadrant I'm in, or if you're in that quadrant, which trig values are positive or negative. And then the tangent value, where I think about slope, or I think about dividing y and x, I'm dividing root 2 over 2 by root 2 over 2. That's just 1. So here we're 1. Here we're negative 1 because I divided a negative, and because it's negative slope. Here we're 1 because we're dividing 2 negatives, so positive. And here we're negative 1, and it's a negative slope again. So kind of those extra tangent values are nice to have. Next, if I go to this point here, which is 60 degrees away, which is important because now we're on a 60, 30, 90, which it's really the same as that first red triangle. It's just oriented in a different way. My radius is still 1. The shorter side, which is now the x travel part, is half as much, so half. And then the longer leg, which is up and down part, is root 3 times as much, so root 3 over 2. So it's the same point, just the x and y are swapped. Furthermore, when I divide them, I'm going to divide in a different direction, so I won't have to rationalize, so the tangent value here is just root 3. And we can flip this point and put them on the other side, and it's the same point, except for in this quadrant, cosine is negative, and tangent is negative, because we're dividing a negative and a positive. And I can flip that boy down here and put him, and it's the same point, except for cosine and sine are negative, but tangent is positive. And I can flip that boy over here, and in this quadrant, cosine is positive, and sine is negative, and tangent is negative. And again, it's not necessarily a 60-degree reference angle. It's 60 above 180, so 120, or 60 after 180, so 240, or 60 away from all the way around, so 300 degrees. or any of our pi over 3 things. So pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. Okay, so this is a lot of information, I know. Hopefully you kind of digested it. I have a fully filled out unit circle that I'm going to give to you guys, but it might be worth it to kind of practice on your own as well. So I'm going to give you this blank one here also, because what's important to know is like not only the degree measure and the radian measure, but also the points. And then it's also important to know that cosine is always your x value. And that also gives me my quadrantal. Oh my god, I forgot to talk about the quadrantal angles, but you guys can kind of see them here. Because if I go all the way up at 90 degrees, I know that point also because I traveled 0, but then fully up 1 because my radius is 1. And similarly here at -1 comma 0, 0 comma -1, 1 comma 0, when I'm back at 360. So anyway, sorry, cosine is always x, sine is always y, and then what might be smart is to add on your tangent values. And so tangent is interesting because root 3 over 3 is like the smallest number, and this is the smallest sloping line. 1 is next smallest, and that's your next one. And then root 3 is the largest. Root 3 is 1.7-ish, so that's bigger than 1, and 1.7-ish divided by 3 is going to make it smaller than 1, so that's why that kind of works out. And so all these tangent values, you know, correspond to the same points in the other quadrants. It's just positive or negative stuff so that you can kind of have your tangent values here. But those two things are super important. And then the last thing I'm going to give you, sorry, I'm like excited and like scatterbrained, but this is also fun, is where we can do our exact values. So trig ratios in our coordinate field when our radius is 1, so when we're on our unit circle, sine will always be y, cosine will always be x, tangent is always y over x, aka slope. Cosecant is sine's reciprocal, so just 1 over y, or I can just like flip it. So in this case, like if I was doing the cosecant of pi over 6, it's related to sine, but then I just flip it, so 2. Secant is cosine's reciprocal, so 1 over x. Now if I were to do the secant of pi over 6, I go to cosine and I have to flip that, so 2 over root 3, which then I'd have to rationalize, so that's a little bit of a process. And then cotangent is just the reciprocal, so x over y, which is just really the opposites of these in other order, in the other order. So, okay. If I'm doing something like finding the trig ratio for a special angle, I do not need my calculator for it. So if I'm doing the cosine of -390, I want to think about that 390 and see if I can relate it back to one of my 30, 60, or 45 reference angles. And I can, because this is 30 more than 360. So this is a 30-degree reference angle. So that's all I'm thinking here, 30 degrees. And at 30 degrees, I'm looking for cosine, and cosine is x. And 30 degrees for cosine at x is root 3 over 2. So I know that's the value. Then I just need to figure out if I'm positive or negative. Now I went negatively, so I'm not necessarily negative, but I went in the negative direction, and I went 360, but then 30 more, because 390. And so really I'm here, and in this quadrant, cosine, or x, is positive, and so it's positive. And like you can draw this out, that's why the little circle's there if you want, but that's really all I do. In fact, once I start doing like evaluating the exact value of a trig function when we're on our unit circle, I actually prefer to be in radians. So I know it's maybe scary and uncomfortable to be in radians, but radians are super nice because I really just need to know about the denominator. So here I'm taking the tangent of -5 pi over 4. When I notice that I was over 4, I automatically know I'm a 45 reference angle. And so anywhere on a 45 reference angle, tangent is always 1. So this is 1. I just need to know if I'm positive or negative. So if I think about what quadrant this is in, negative 5 pi over 4 is going in the negative direction. So for me, I refer it back to like a fraction that I know, like 4 over 4 is 1, but then I'm more than that. So I'm in this quadrant, and in this quadrant, tangent is negative because all these lines are negatively sloping. So negative 1 is my answer. All right, cosecant is, now I know the reciprocal functions are tricky, I'm not going to have you do too many of them, but cosecant is sine's reciprocal, so really I'm thinking like sine-ish. Now, of 4 pi over 3, and again, radians are nice because if I know what I'm over, I know what I'm referencing, and if I'm over 3, I'm referencing a 60-degree angle. And so if I'm looking at 60, no matter where I go, sine, or cosecant, it's reciprocal, is always y, which is root 3 over 2. But because I'm doing cosecant, I need to flip that. It's actually 2 over root 3 because we're doing the reciprocal, and then I need to rationalize that. So 2 root 3 over 3 is the answer, but I need to know if I'm positive or negative. So since I'm 4 pi over 3, I'm traveling in the positive direction, and I went 3 pi over 3, but then 1 more, so I'm in this quadrant. And in this quadrant, sine, or cosecant, is negative because it refers to y, and everything y value is negative in this quadrant. So this is actually negative. Example 2 in here we're not going to worry about, so don't even look at that. You know what, we really don't need to worry about example 3 either. Just make sure that if you're looking at degrees and you can't do it in your head, that you need to be in degree mode. And if you're looking at radians, make sure that you're in radian mode. And actually, maybe I will do this one real quick because like 235, if I'm ending in 5, I'm hoping that I'm at a 45 reference angle, but it's actually not. 225 is. So this one I have to approximate. I can't use my fun little triangle. I have to go on my calculator and make sure that I'm in degree mode, which I am. So I would do 235 sine, so negative 0.819. Cosine of negative 35, also have to approximate that because it's not a 30, 60, 90 or 45, 45, 90. And so in my calculator, again, I got to do 35, change it to negative, and then take the cosine of that. So 0.819. Oh my word, look at you two being the same. That's cute. Did I hit the right button? Let me just double check. No, I'm super nervous. Okay, yeah. Okay. Boop, boop. But the last one, if you notice, there's a straight up equal sign, and that's because I can take the cotangent of negative 180 because 180 is one of my quadrantal angles. Oh my god, we didn't even talk about tangent on my quadrants. That's okay, we can do it right now. Here, since tangent is slope, the slope of this line is 0, which makes sense because if I do y over x, 0 divided by 1, that's 0. So this is also 0, which gives me my answer here, negative 180. The cotangent is 0. Oh, no, that would be tangent. If I'm here, the slope of this line is undefined. And also 1 divided by 0 is undefined, so that makes sense. But the reason I came back to that is because cotangent is tangent's reciprocal. So at negative 180 or 180, tangent is 0, but the reciprocal of that is undefined. Oh my god, your calculator will do it for you too, just in case you're like not super sure, because you can type in 180, put that negative boy, and then take the tangent of it, I guess, because I don't know, can we do reciprocal functions on here? I don't know. Tangent. 0, and then reciprocate it. So I guess you still have to do the reciprocal part on your own. I don't know if I can get, no, those are inverses. These are hyperbolics. I think that's different. Anyways, last but not least, the radians. If I'm over 8, then I'm not a reference angle, so I'd have to do this on my calculator. And this is where you want to make sure that you change the mode. So we don't want to be in degree mode anymore. We're going to change to radians. So now I can see that I'm radian mode. And we're going to do 3 times pi, which you do have a pi button, equals, and then divide that by 8. And then we're going to take the secant of it. Oh crap, I'm going to have to take the cosine of it and then flip it. So that and then flipped. Oh my gosh, I don't know how to do that on here. I'd probably use Desmos for that one. But let's try the next one because tangent isn't a reciprocal function. So we can do 5 times pi. Then divide that boy by 12. And I needed to do that because like 12 under here is not a reference angle to a 30, 60, or 45. And then we're going to take the tangent of that. So 3.73-ish. Now in the last one I don't need to do it because I'm over 4, and over 4 is always a 45-degree reference angle. And 45 reference point is root 2 over 2 comma root 2 over 2. And cosecant is sine's reciprocal, and that's going to be root 2 over 2, but I got to flip it, so 2 over root 2, and then rationalize it. Oh my word. So 2 root 2 over 2, that's just root 2. But then, am I positive or negative? And so if I'm 6 pi over 4, oh my word, that reduces. I just did that all wrong. Oh well, living in the moment, because that's really negative 3 over 2. That's a quadrantal angle. That is, well, here, but negatively, so really our 90 degree. And at this spot, cosecant, so sine is 1, and the reciprocal of 1 is just 1, so 1. Oh my word. That was a big old oof. Anyways, I'm going to post a Quizlet with a ton of these on there because you're just going to want to go through them a bunch of times and try to like know them, know them to your core, like in your soul. You just know them. Like, what is the sine of 7 pi over 3? Oh, not 7 pi over 3, 7 pi over 6. So sine of that is negative half. Or what is the cosine of 300? And that's half. Or what is the tangent of 3 pi over 4? That's going to be negative 1. You just want to know them, like the back of your hand. Okay, sorry, I'm rambling. I'm done. Good luck, you beautiful people.